Multiply the polynomials. We have 3x times x squared minus 3x plus 1. When you have a single term outside of your parentheses, you multiply with the distributive property, 3x times x squared. Your coefficients are 3 and 1. Those are multiplied. Your powers are 1 and 2. Those get added. Do that for each step. 3 times negative 3, x to the 1 plus 1. 3x times 1, that's 3x. In the example to your right, we have y squared times 4y squared plus 2y minus 3. Again, we have a term times 2 or more terms. That's going to use distributive property. 1 times 4, y to the 2 plus 2. Second jump, 1 times 2, y to the 2 plus 1. And third jump, 1 times negative 3, y squared. When you're multiplying more than one term against more than one other term or several terms, in this first case we have a binomial, 2 terms, times another binomial. Each term in the first set of parentheses will be distributed to each term in the second set of parentheses. Starting with your 7x, we take 7x times 2x. Then we take 7x times negative 4. Switch to your second term, negative 3 times 2x, negative 3 times negative 4. Now, since the outer terms and the inner terms were both x terms, I stack those vertically. If a term doesn't have a like term, you just recopy it. But if there are like terms, then you add or subtract their coefficients as appropriate. Negative 28 minus 6, that's negative 34 of the x-type term. 12 is a constant, there's no others, so we just recopy it. In the example to your right, we have 3 terms. We're going to start with the x squared, distribute it. X squared times x squared times x, that's x cubed. X squared times 7, 7x squared. And then we move to our middle term, negative x times x squared, that's negative x cubed. Negative x times positive x, that's a negative x squared. Negative x times 7, that's negative 7x. And then we move to our third term, 3 times x squared, 3 times x, 3 times 7. Like terms I have stacked vertically. X to the 4th is the only one of its type. We have a couple of x cubes, but 1 minus 1 is 0. We don't have an x cubed total in the final answer. Then we move over to the x squareds. 7 minus 1 plus 3, that's 9 total of the x squareds. Negative 7x plus 3x, that's negative 4x. And then 21 is the only one of its type. Find the special products. We have binomial times a binomial. The only difference is the sign in the middle. Starting with your 2x, 2x times 2x, 4x squared. 2x times positive 3 is 6x. Negative 3 times 2x, that's negative 6x. Negative 3 times positive 3 is negative 9. If your binomials only differ by sign, then the terms in the middle will add up to 0, leaving you with your first term, 4x squared, and your last term, minus 9. In the example to your right, we have 2x plus 5 quantities squared. Excuse me. If you square just a number term like 7 squared, that's two 7s multiplied together. And the same thing works out with algebraic terms. If it's all squared, that just means there's two of them. So if we take if we take two 2x plus 5s and multiply them, we'll have 2x times 2x, 2x times 5, that's 10x. Move to your 5, then that's 10x and 25. This time the terms in the middle add up to a total of 20 x's. So we have 4x squared plus 20x plus 25. The opposite of multiplying with either repeated distribution or just a single distribution is called factoring. Factoring is when you divide out the most you can from your coefficients, and then you take out the smallest amount of variables because that's all they have in common. 3 and 9 are both divisible by 3. We have x cubed, x to the first. The smaller of those is x to the first. So this is called your greatest common factor. Take each term, divide by 3x. 3 divided by 3 is 1. X to the 3 minus 1 is 2. There's 2 remaining. Move to your second term, negative 9 divided by 3. That's negative 3. When you take out this x, there's no x's left inside. The example to your right, 3z cubed minus 6z squared plus 9z. All of your coefficients, the most you can divide out of those is 3. And out of the variable terms, z to the first is the smallest. That's the most they have in common, though, so you have to look at it that way. Dividing each term by 3 and removing a z, that's going to leave a couple of z's from the first term. Negative 6 divided by 3, that's negative 2. Take away a z, there's still a z left. And then on your third term, 9 divided by 3 is 3. Take your z out, and there's no more z's. A special type of binomial is called a difference of two squares. Each of these two terms are perfect squares. Now 25 and 36 don't have anything in common, so we can't divide any numbers out initially, but that's okay. If we take the square root of 25m squared, we get 5m. And if we take the square root of 36, we get 6. A few problems ago, one of our special products, we saw that if you have two binomials that only differ by sign, then the terms in the middle will fade away. They'll go to 0. If we put in a plus and a minus sign, that will, from this term, you'd get negative 30m. From multiplying these two terms, you would get positive 30m. See, we're missing an m term. We only have the m squared and the constant. So with difference of squares, you take the square root of each term and you throw in opposite signs. In the example to your right, 18x squared minus 32, we have a difference of two terms, but they're not exactly perfect squares. Both of these two numbers, 18 and 32, they're divisible by 2. So when you investigate your original problem, you want to divide out the greatest common factor if possible. The best we can do for this one is 2. 32 doesn't have a variable, so 2 is the most we can divide out of both terms. 18x squared divided by 2 is 9x squared. 32 divided by 2 is 16. This exposes a difference of two squares. We keep our 2, it's part of the original problem. Square root of 9x squared is 3x. Square root of 16 is 4. And just remember to use opposite signs. Below, we have a couple of perfect square trinomials. Now, these are three-term expressions, and the idea is to break these down into parentheses as far as possible. Now, our x squared will break down into x times x. 4, that's 2 times 2. Just make sure that you arrange your signs such that with a trinomial, if the last sign is positive, you'll use the first sign twice. Since that leads to identical factors of x minus 2, we can write this as x minus 2 quantity squared. Below is the formula for your perfect square trinomials. You have a square in the front, a square in the back. Those square roots go together, match the first sign. In the example above, if you were to match this formula with it, this would be your u squared term. That's your lead term. Its square root is x. So you have u squared in the front. You break it down with a square root, that's u. X squared goes to x. The back term was 4, which is 2 squared, so 2 goes here. With perfect square trinomials, it takes some work to get used to the formulas. In fact, I just recommend breaking this down into identical factors and squaring at the end. If you were to multiply out x minus 2 times x minus 2, you would get x squared minus 2x, another minus 2x, that's where you get your minus 4x, and then two negative 2's make a positive 4 when you multiply them. Excuse me. In the example to your right, same situation. 4x squared is a perfect square, and its square roots to 2x. 1's a perfect square, and its square roots to 1. 1 times 2x doubled, that's what this 2 UV in the middle is 4x. So it does follow a pattern. You just have to be careful getting it to line up. 4x squared has a square root of 2x. 1 is square roots to 1, and you just make sure you put the plus sign. Again, on trinomials, when the last sign's a plus, use the first sign twice. And then finally, we're going to look at a couple of different types of binomials. We've looked at difference of two squares. For this slide, we're going to look at the sum or difference of two cubes. If you have cubes, they can be separated by a plus or a minus sign. With squares, they need to be separated by a minus sign. The formula is at the bottom of your screen, and I'll show you how to apply that. Take our first problem, x cubed plus 27. Take the cube root of each term. X cubed is the cube root of it is x. Cube root of 27 is 3. Once you've got your first set of parentheses built, the second set is built from these terms. Square the first term, list it first, x squared. Square your last term and list it last. Then multiply these two and change the sign. That's negative 3x. In the example to your right, the cube root of 27t cubed is 3t. The cube root of 343 is 7. Square the first term, you get 9t squared, list it first. The second term, you have 7 squared, that's 49, list it last. Multiply 3t and 7, change the sign, that's negative 21t. And then we have a couple of factor each trinomial problems where the x squared term has a leading coefficient of 1. If you have a trinomial with a leading 1, you take the last number from your problem, which is 2. The only factors 2 has, because it's prime, are 1 and 2. The idea for factoring a trinomial is you pick a pair of numbers that will add up to the middle value, which is positive 1, and multiply to the last value, which is negative 2. So if we take our factors of 2, which are only 1 and 2, if we use a negative 1 and a positive 2, the sum of those numbers is positive 1. The product of those two numbers is negative 2. And so negative 1 and plus 2 finish the parentheses. Excuse me. X squared you break down to x times x. And then you put in a minus 1 and a positive 2. In the example to your right, we take the last number 6. 6 has a couple of pairs of factors, 1 times 6 or 2 times 3. We have to pick a pair such that the sum is negative 5 and the product is 6. If we try the top pair, if you add 1 and negative 6, you can get your negative 5, but the product is not positive 6. So we have to move to the second pair of numbers and try negative 2 and negative 3. If you add negative 2 and negative 3, you get negative 5. If you multiply them, you get positive 6. Since this pair does both jobs, those are the two numbers you put in the parentheses. So this trinomial will factor as x minus 2 and x minus 3. If you were to remultiply those, you would see that these two multiplied back out do give you x squared minus 5x plus 6.